Yep, you're continuing with Binomial Probability Day 2, 7.6. Our objective is to continue working on finding binomial probability. Here we're going to start talking about more interesting binomial probabilities. So more interesting binomial probability occurs when we consider at least and at most. So we talked about successor being specifically 4, 2, 3, 10, or whatever. Now, in this section, this unit, this lesson, actually, we're going to talk about at least and at most. So um, the key of doing these is that we need to know here what's going on. So remember, we already saw this when we see the word or. So in events, let's say event 1, 2, 3, blah, 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 are a mutually exclusive event, meaning they're happening. So it's the probability of event 1 or event 2 or, so forth. And we know when we see the word or, it means the probability of event 1 plus the probability of event 2 and so forth. We can use this concept to combine multiple binomial probabilities to solve more complex problems. So let's look at exercise 1. It says Jen has taken 5 questions on a multiple choice quiz, where each question has 4 choices on it. If she randomly guesses at each question, determine the probability that she will correctly answer at least 4 out of 5. Now, what does at least 4 out of 5 mean? So at least 4 out of 5 means she can get 4 questions correct or she can get 5 questions correct. So we need to find what's the probability that she will get 4 out of 5 questions correct. So it's probability there are 5 questions, she needs 4. And if there are 4 questions, that's 1 out of 4 choices, that's my P. And then 3 out of 5 is my remainder, which is the 1 question that she will get wrong. You put this identical in the calculator, you will get 15 out of 1,024. Now it says at least 4, so that means she can also get 5 out of 5 correct. So the probability of getting 5 out of 5 is 5 choose 5, and then it's a quarter out of 5, and 3 out of 4 will be a 0. This will give us 1 over 1,024. Now again, just remember, how did I get this? Remember, multiple choice, A, B, C, D. There's 1 correct answer, and then these 3 goes up to here. So remember, we talked about this in the previous lesson. So there's 1 out of 4, and then the 3 choices. So now the probability, we want to write this out as the probability of at least 4 out of 5 will be the 15 out of 1024 plus the 1 out of 1024, which we know is going to be 16 out of 1024. You can simplify or leave as is, up to you. Alrighty, let's continue to exercise 2. On a tropical island, it consistently rained 40% of the day. Over the next 7 days, find a probability it will rain at most 2 times. So at most 2 times means it can rain 0 days, it can rain 1 day, it can rain 2 days. So we have to find the probability of each. So the probability that it will rain 0 days of rain, that's fine, will be equal to, let's just move this piece here up a little, will be equal to, there's 7 days, so 7 choose 0. what's the probability? So it'll be 0.4 and then 0.6 will be a 7. Now, be careful because your P, your success is 40%. Oops, not 4%, 40. 40%, which is the same thing as 0.4. And then your Q, your failure, is the 60%, which is 0.6. So that's where these numbers are coming from. I worked this out in the calculator. I will get 0.0279. Let's just leave it as that. So that's the probability of 0. So the probability of 1 day of rain will be the same thing. 7 choose 1, 0.4 to the first power, and then 0.6 to the sixth power. Plug this in the calculator, I will get 0.1306. Let's just use 4 decimal places. And then the probability that it will rain 2 days of rain, will be 7 choose 2, 0.42, and 0.6 to the fifth. This will give me 0.2612. Then we need to remember, so the probability at most 2 days of rain will be 0.0279 plus 0.1306 plus 0.2612, which is equal to 0.4197. And this will be the probability that it will rain at most 2 days. Now be careful, this question did not ask me to round it, so I just use 4 decimal. Most of the time you can use all the decimals, that's perfectly fine. Just be careful what's being asked. Now, moving along, we're going to talk about something called complement. To find the probability of an event is sometimes easier if we find the complement, its complement, and then use the relationship. So, the probability of an event and its complement is that the probability of that event plus the complement is always 1. More useful, which is what we see all the time, is the probability of an event is 1, take away the complement of that event. So let's see what this looks like in exercise 4. A fair coin is flipped 10 times and the outcome is recorded each time. Let E be the event of getting at least 2 heads on a 10 flip. What is the complement of this event? So try to think about, the event is getting at least 2 heads on a 10 flip. The complement would be what? The complement is getting at most 1 head. So complement, the complement here is getting at most 1 head, which is the same thing as the complement is the event of getting 0 or 1 head in the 10 flips. Again, look at what it says. The event is getting at least 2. So at least 2 heads means 2, 3, 4, 5, 6, 7, 8, 9, or 10. The complement will be the reverse, the opposite, which is getting at most 1, which is getting 0 or 1 head when you're flipping those coins. Now find the find the probability of the complement. So we already know what the complement is, so we want to find the probability. The probability is getting 0, so it's 10 choose 0, which is when you're flipping a coin, it's 1/2 of 0, 1/2 of 10, plus the probability of getting one head, which is 10 choose 1, is 1/2 1 and 1/2 to the ninth. Work this out in your calculator. The same exact way, you will get 11 out of 1024. So again, the complement is the probability of getting 0 plus the probability of getting 1 head. Use your answer in B to determine the probability of the event. So the probability of some event is equal to 1 minus the probability of the complement. So this will be 1 take away 11 out of 1024. Put that in your calculator. You get 1013 over 1024. And this will be your final answer. Last question says, to the nearest tenth of a percent, what's the probability of getting at least one head on 4 flips? So at least one head, think about what at least one head means. At least one means you can get 1, 2, 3, 4, 5, 6, 7, so forth on a 4 flips. So it's going to be at least one, can be 1, 2, 3, or 4. So the easiest thing to do, and I think I want to write this down, at least one head means 1, 2, 3, or 4. So the probability of at least one head is going to equal to 1 take away, and I need a little bit space, is going to be 1 take away the probability of getting no heads. You can also do the probability of 1 head plus the probability of 2 head plus the probability of 3 head plus the probability of 4 head, but this is way easier. So this works out to be, so I will now have 1 take away the probability of getting no head would be 4 choose 0, 1/2 0, 1/2 4, and this will work out to be, let's see where I can get some. So put all of this in your calculator and you will get that this works out to be equal to 0.9375, and because it's asking me to the nearest tenth of a percent, I times this by 100, which will give me 93.75, which is approximately 93.8%. Just be careful with the rounding. Now going to exercise 5, it's a little cool carnival game. It says, going down here, let me scroll down a little. A carnival game is created where contestants throw bags at a board shown below, which consists of 4 congruent triangles, one of which is painted black. The contestant paid $3 for 2 bags and will win if at least one bag lands on the shaded area. Assume that the bag always falls in the overall area. What is the probability that the ball will land on the shaded section? So again, simple. This is an easy one. There one section, I can use black because you can't see the black over. There will be one section. This is 2 section, 3 section, 4. So the probability that it lands in the shaded section would be 1 out of 4. That's my P. This is my successor, that's my P. So therefore, Q would be 3 out of 4. Determine the probability if Joshua wins the game if he plays it once. So probability of winning, the probability of win, and it says how can they win if at least one bag lands in the shaded area. So does the probability of win is the probability of one bag or 2 bags landing in that area. Okay, this works out to be 2 choose 1. What's the probability? A quarter, and then 3/4 says nope, plus 2 choose 2, a quarter, and 3/4 goes to 0. And I'm just going to bring this out here. This is actually going to work out to be 6/16 plus 1 over 16, which is equal to 7 over 16. So that's the probability that he will win. Remember, it says that a contestant pays $3 for the bag will win if at least one bag. When they pay $3, they get 2 bags, so at least one of them. So to win, you have to have 1 bag or 2 bag landed in this shaded section. If Joshua plays the game 3 times, what is the probability he will win at least once? Round your answer to the nearest percent. So probability, let's get a different color out here so you can see the difference. Probability of winning at least once is going to be equal, we don't need that, is going to be equal to what? Is going to be equal to, here we go, 1 take away the probability that Joshua won't win at all. So probability of him winning is a complement, 1 takeaway that he won't win at all. So now we need to find out what's the probability that he won't win at all. So it's going to be 1 takeaway. He's playing how many times? He's playing 3 times. 3 choose 0, and he's losing. We know that the probability of winning is 7 out of 16. Okay? And then this will be 9 out of 16. How did I get this? The probability of he won't win. Remember, in part B it says determine the probability if he wins at 1. So this is the probability, 7 out of 16 is what he's going to win. So we want to find a probability that he won't win, so that means it's 0. Put all of this in your calculator, it ends up to be 1 take away 729 over 4096, which is going to give you, from your calculator, is 3,367 over 4,096, which is going to be equal to 0.8220, and from here to here you press Control Enter. You're going to get the decimal, but it wants your answer in percent, so that means I need to multiply it by 100. This will give me 82.20, and they want it to a nearest whole number, which is approximately 82%. So this question is actually testing a lot of skills here. You had to find regular probability, the probability he's going to win, and then you have to find the complement. Alrighty, I know it's been a long lesson. We're almost there. We have one more lesson to go for Unit 7, which is probability, and more probability. Good luck!